Hello, welcome to this video. This is Differential Equations, lesson 8-1 for the Essentials of Calculus, and we're going to talk about how to solve differential equations. All right, so it's important to note that differential equations are equations with derivatives in them, and in order to solve differential equations, what we'll end up doing is separating the variables. So you kind of know that we have a slope, which is dy dx, and what we're going to do is split up those variables. Now, when we solve these, what we're going to do is we may be asked to find a general solution, and when you have a general solution, that's when we're going to leave a plus c tacked on in our equation. Now, the other type of differential equation that they may ask us for is a particular solution, and this is when we're going to have a point, and we have to go ahead and evaluate at that specific point. Okay, so we'll look at some examples. Here are the procedures for solving differential equations. We're going to rewrite y prime as dy dx if necessary, and then what we'll do is we'll put the x's with the x's, the y's with the y's, and that's kind of step 2 and 3. So separate your variables and split apart those dx's and dy's. Step 4 is to integrate. Now, it's important to remember that we add our plus c, and what we only have to do is add it to one side, and generally we'll do that on the side with the x. Step 5, solve for y if necessary, and then step 6, you'll use an initial condition to go ahead and solve for c if that's what they want, if they want a particular solution, okay? So let's go ahead and look at the first example here, and we are asked to find a general solution of x plus 2y y prime equals 0. Now, it's important to note that, again, when they say the general solution, okay, I don't have a point to plug in. We can go ahead and leave it as a plus c. All right, so we'll go ahead. Step 1 here, it says first rewrite the equation as x plus 2y dy dx, right? And all we're doing here is swapping out the y prime for our dy dx. Now, the reason for this, right, is I want to go ahead and separate my x's and my y's. So we have 2y dy dx is equal to negative x. Now, what we want to do is go ahead and I want to put that dx with my x. Whoa! The lights went out. Man. All right. I want to put that dx with the x, okay? So now what we have, right, after these cancel, is 2y dy is equal to negative x dx. All right, so now that my variables are separated, okay, that is steps 2 and 3. Right, steps 2 and 3. Now what we want to go ahead and do is integrate. Step 4, integrate, okay? So I'm going to integrate this side, and I'm going to integrate this side, okay? Now what we get is 2y squared divided by 2 is equal to negative x squared divided by 2. And since I integrated this as indefinite, we're going to add a plus c. Again, I only needed to do it to one side. Why not both sides? Well, I mean, it's a constant on both sides, right? So if I put them together, it's still a constant. So again, you only have to do that on one side. All right, so after we go ahead and kind of clean this up, we have y squared is equal to negative 1/2 x squared plus c. Now, I want to go ahead, step 5, it says solve for y if necessary, and that's kind of what we're going to do here. It says write your solution to example of 1 as a pair of possible functions in the form y equals f of x. Okay, so if I go ahead and I take the square root of both sides, I'm going to have two different equations. I'll have a positive square root of negative 1/2 x squared plus c, and I will also have negative square root of negative 1/2 x squared plus c, right? So two separate equations there. All right, that's example 1. Let's go ahead and look at example 2, which in example 2, they ask us to find an equation of a function that contains a specific point. 0, negative 3, whose slope is x times e to the power of x squared divided by y for each point x comma y on the curve. Okay, so what they give us is a slope and a point, and they want the particular solution, right? So anytime you see point here, this is where they want a particular solution. Okay, so what we're going to go ahead and do, the steps are exactly the same, except we're going to have to go ahead and evaluate at that point to solve for C. Okay, particular solution, this kind of means solve for C. All right, so let's go ahead and take this information and solve it. Okay, so they say the slope is this. So slope, we know, is dy dx is equal to x times e to the power of x squared over y. All right, so I want to separate my variables, right? That is steps 2 and 3. So we're going to go ahead and I'll multiply each side by y, giving us y dy over dx is equal to x times e to the power of x squared. And now what I want to do is I want to go ahead and multiply each side by dx. Okay, so what we get is y dy is equal to x e to the power of x squared dx. All right, so now my variables are separated, and what I want to go ahead and do is now integrate. Okay, so now I'm going to integrate, and on the left, this is a simple integration. We have y squared over 2 is equal to, on the left-hand side, note I have an exponential, and I have two separate functions here, so I'm going to go ahead and investigate. I'll look at this x squared and say, okay, what's the hook of that function, which is 2x. Note, I already have an x accounted for, so I have to go ahead and introduce a 2. So here's what I'll go ahead and do. I'm going to introduce 1/2 times the integral of e to the power of x squared. And I'll put the 2 that I'm introducing here along with this x back here with the dx. Right, so here's the hook factor, or our reverse chain. Okay, I introduced the 2, I balanced it with a 1/2, and we get y squared over 2 is equal to 1/2 e to the power of x squared plus c. All right. So note, I don't have this particularly solved just yet, right, for y. So what I'm going to go ahead and do is multiply both sides by 2. Right, I'll multiply this side by 2. And we get y squared is equal to e to the power of x squared plus 2 times c. Well, 2 times c, that is still a constant, right? So that's still c. And then what we'll go ahead and do is take the square root of each side. Okay, so we get y is equal to plus or minus the square root of e to the power of x squared plus c2. Okay. All right, now what we're going to do at this point is we're going to go ahead and plug in our point. So I'll switch to a different color here. And I want to notice how we have 2 equations. So which equation am I going to use to go ahead and solve with this point? And I want you to notice the y value. The y value is negative. So what I'm going to use is I'm going to use the negative function only. So negative root e to the power of x squared plus c2, okay? And what we're going to do is we're going to go ahead and plug in this point. So negative 3 is equal to negative square root of e to the power of 0 squared. So that's just 0 plus c2, okay? So we're going to go ahead and solve this. So this gives us negative 3 is equal to negative 1 plus c2, and we'll go ahead and solve. So I'll square both sides. Okay, and we get 9 is equal to 1 plus c to the power 2. We'll subtract 1 on both sides, and we get c is equal to 8. Okay, so what is our particular solution for that point? Well, I'm going to go ahead and do is just plug in 8 into our equation up here. Okay, so y is equal to negative square root of e to the power of x squared plus 8. Okay, and that is your particular equation. All right. Okay, one last example. And example 3 is a little bit tricky, okay? So let's go ahead and see what we have to do here. All right, so again, step 1, I want to go ahead and rewrite as dy dx. That's already done for us. Step 2, I'm going to go ahead and multiply both sides of the equation by dx. Okay, I'll separate my x's and y's. Okay, so this gives us y minus 2 dx is equal to x times dy. And if you're looking at this, you're like, hey, the y's and the x's, they aren't on the same side together. Well, what we have to go ahead and do is we have to go ahead and make that happen, right? So I'm going to go ahead and divide both sides by x, and then I'll divide both sides by y minus 2. Okay, now, again, okay, the reason I'm doing this is to put my x's with my x's and my y's with my y's. So what we get is 1 over x dx is equal to 1 over y minus 2 dy. Okay, now what we're going to go ahead and do, I have my x's with my x's, y's with y's, and I'm going to integrate each side. All right, so what is the integral of 1 over x dx? Hey, we just learned that. That is the natural log of the absolute value of x plus c, which is equal to the natural log of the absolute value of y minus 2. Okay, so there's our function, and now what we want to go ahead and do is solve for y. How do I solve for y? I have to get rid of that natural log. So how do you undo a log? Well, with an exponential of the same base. So what we're going to do is I'm going to raise each side to the power of e, right? So, or raise e to the power of each side, right? So what we get is e to the power of ln of absolute value of x times e to the power of c, which is equal to, note this just becomes the absolute value of y minus 2. All right, so now how the heck did I get this? Well, remember, right, if I have if I have variables that are multiplying, right, this is this property right here. So a to the x times a to the y is equal to a to the power of x plus y. So I just went ahead and I separated these, okay? And e to the power of c, that's just a constant, right? So I have c to the power, or c times, okay, e to the power of natural log of absolute value of x. Well, again, e and natural log, those are inverses, so we have the absolute value of x, which is equal to absolute value of y minus 2. Okay, now how do I deal with the absolute value symbols? Well, just I want to remind you, right, the absolute value of y, if it's equal to 2, then y is either equal to plus or minus 2, right? This is just kind of a side note here. So we want to go ahead and solve this. Well, what we do is I just remove the absolute values and I put plus or minus on each side, right? So this gives us plus or minus c times x is equal to y minus 2. Okay, and again, right, plus or minus c, that's just c, it's just a constant. So what we get is y is equal to, after I add 2 to both sides, is equal to cx plus 2. Okay, so there is our general solution for this example. Okay. All right, and then lastly, what we're going to go ahead and do, part B, it says find a particular solution of that equation if y of 1 is equal to 1/2. So all I'm going to go ahead and do is plug these values in. 1/2 is equal to 1 times x plus 2. So we'll subtract 2 on each side, and we get x is equal to negative 3/2. So here's our specific or particular equation that they want. Okay, and that is it. That is differential equations. All right, give me a like, subscribe. I'll catch you next time. Peace.